For centuries, humanity has gazed at the stars, wondering if we are alone in the vast cosmos. Are there other intelligent civilizations out there? If so, how many? In 1961, an astronomer named Frank Drake proposed a way to estimate the number of extraterrestrial civilizations in our galaxy, the Drake equation. Join us as we unravel this fascinating formula and explore what it means for the search for alien life. The Drake equation was first introduced at the first scientific meeting on the search for extraterrestrial intelligence, or SETI. Frank Drake, an astrophysicist, wanted a way to quantify the probability of finding intelligent life beyond Earth. His equation doesn't give us an exact number, but rather a framework to estimate the potential number of civilizations in our galaxy capable of communication. The equation explained: N, R, XFP, XFL, XFL, XFC, XL. The equation consists of 7 factors, each representing a crucial step in the process of forming intelligent, communicative life. Let's break them down, one by one. R represents the average rate of star formation per year in our galaxy. Astronomers estimate that the Milky Way produces about 1 to 3 new stars each year. Since planets form around stars, this number sets the foundation for the rest of the equation. Next, we consider FP, the fraction of stars that have planets. Thanks to modern exoplanet discoveries, we now know that most stars host planetary systems. Current estimates suggest that nearly every star has at least one planet, making this fraction close to 1. Not all planets are suitable for life. The number of planets per system that fall within the habitable zone, or the Goldilocks zone, where liquid water can exist, is called Ne. Recent studies suggest that around 20 to 25% of stars might have at least one Earth-sized planet in this zone. Just because a planet is habitable doesn't mean life will form. The fraction of planets where life actually emerges is full, remains one of the biggest unknowns in science. Some believe life may be common in the universe, while others argue that it is an extremely rare event. Even if life emerges, will it become intelligent? The fraction of life bearing planets that develop intelligent species, phi, is another uncertain factor. It took Earth billions of years for intelligence to evolve, and we don't know if that is the norm or an anomaly. A planet might harbor intelligent beings, but will they develop technology capable of communication? The fraction of civilizations that develop radio or other communication technology, FC, is crucial for detecting alien life. After all, we can only detect those civilizations that actively send out signals. Lastly, we consider L, the length of time a civilization remains communicative. Some civilizations might last for millions of years, while others may destroy themselves quickly through war, resource depletion, or environmental collapse. This factor greatly influences the overall number of detectable civilizations. When scientists plug in various estimates, they get widely different results. If all factors are optimistic, the Milky Way could host thousands or even millions of communicating civilizations. If pessimistic, we may be the only one. If the Drake equation suggests many civilizations could exist, why haven't we found them? This is known as the Fermi paradox. Some possible explanations include civilizations being too far apart, using undetectable technology, or self-destructing before we can find them. Scientists actively search for alien signals using radio telescopes and new technologies like laser communication. The SETI Institute, NASA, and private initiatives like Breakthrough Listen continue to scan the skies. In 1977, we detected the famous WOW signal, but its origin remains a mystery. With powerful telescopes like the James Webb Space Telescope and upcoming exoplanet missions, we may soon detect biosignatures, chemical traces of life, in distant atmospheres. Advanced AI-driven SETI searches could also uncover hidden patterns in cosmic signals, If we discover intelligent life, it would be the most profound event in human history. Would they be friendly or hostile? Could we even communicate with them? The search continues, and with each discovery, we move closer to answering the ultimate question: are we alone? Enjoy the cosmos journey? Like, subscribe, comment. Keep looking up. The universe might surprise us.